Good morning, everyone. It's a privilege to be here. My name is Tom Katsioulas. You can call me Tom Cat. This is a pretty broad presentation, so we're going to keep it at a very high level. For those of you who will later record this, there will be speaker notes, there will be a glossary, and also be URL links that you can actually go reference anything that I would present. Fundamentally, we're living in a very changing world. Between IoT, 5G, and AI, there will be an explosion in terms of where the world will go, both in terms of innovation and economics. And all that starts from chips that go to devices that will go to edge applications. And the ones that have the highest value analytics originally will be essentially manufacturing, critical infrastructure, and connected environment. Three messages. IoT will be transformative together with AI in our future society. It will change a lot of things. However, the barrier to adoption, which is what we're trying to solve in the IoT Advisory Board, is going to be huge because primarily of supply chain resilience and security. And the call to action is that several allied nations that need to get together and collaborate in orchestrated ecosystems to be able to drive the entire value chain from chips to edge and edge intelligence thereafter. So let's see if this works here. Trying to get the
arrow down.
Let me see, maybe I need to turn it on.
You can use the laptop, the arrows.
Okay. All right, so let's start with the numbers. We're going to go through a journey. We're going to go business, operational, and going to finish very technical. Fundamentally, the McKinsey, which is a very famous research firm, projected at the World Economic Forum 2014 that IoT, 5G, cloud computing, and AI will basically contribute approximately between 9.6 to 21.6 trillion in the global economic value. They were off. Then they revised that again in 2014, and they said that number should be between 5.5 to 12.6 trillion value in the global economy, but they gave a min-max range basically on three factors: impact, scale, and adoption. The adoption is the one that is lagging, even though the potential is extremely significant. Then you look at the local European analysis and what happened in the global IoT space. This is from Decision Council. In 2021, we have 841 billion euros, approximately $1 billion in different marketplaces for IoT. And the ones that are growing the fastest are the ones that have the highest analytics value: automotive, healthcare, industrial, and factory automation. Interesting enough, they're not the highest volume of chips, but it's the highest value in terms of analytics applications and services. So why is IoT not growing so fast, and why we were called as an advisory board to figure out the barriers of adoption? People talk about infrastructure, security, interoperability, lots of factors. But I contend there are two major factors. One is, how do we move from a legacy infrastructure to essentially enable IoT, and the second one is the diversity of the expertise to put together solutions end-to-end is so great that it requires ecosystem collaboration orchestration. Therefore, when you start in the environments that McKinsey talked about, smart city, supply chain, critical infrastructure, every other market that we serve is essentially part of that operating environment. And that's extremely important because when we talk about edge applications, they have a variety of use cases, starting from the IT edges, which is the compute data centers, and how do you actually deal with connected devices there that exchange data, going to the IoT edges, which is mostly the consumer IoT devices that have built-in sensors, etc., going all the way to the OT edges with industrial, where essentially you have complex disaggregated systems with IT being the 20 boxes in your IT, in the nuclear power plant, driving another 1,000 PLCs. That can be invaded. So this is very important. The second thing is IoT is about connectivity. So we're saying that if you want to think about IoT as you being an IT supplier, don't think of you as a supplier of IT devices. Think of you of a supplier being connected to the customer via IoT. And that's very, very important because you ship devices, we're going to see a lot of evolution in what we call product as a service. We sell a hardware product, but the services after that is what matters. And we create the concept of digital marketplaces that can give feedback to the supplier. And if you can actually become a smart connected supplier, not just a provider of smart connected products, then you can have all kinds of benefits. Visibility in supply chain, remote lifecycle management, reduce support, lower cost of support. But connectivity opens up Pandora's box in terms of security, trust, and how do you do the data sharing. And that's really the essence of how we can move about monetizing it. So how do we leverage that connectivity to basically drive both security and economic growth? Well, it starts by saying to look at how the evolution of a product goes, and there are products in industries that are more lagging in IT and others that are ahead of IT. So if you look at the tractor, we're going essentially, the base of competition is changing, whereby we're going from a product, a smart product with some dashboards, a connected product, and eventually becomes an integrated equipment which connects to the rest of the ecosystem, whether this is weather and sea optimizations, etc. All right? And then if you actually go one level up in criticality and you replace the tractor with a plane, you got more complicated dashboards. But at the end, this is the same structure because fundamentally, only the application software changes at the edge, all right? But the products become connected, and these bubbles next to the product indicate that you need to build a partner ecosystem in order to provide solutions that will allow you to give you services and monetize those services. And if you think about what these products do, it's very much the same because you got to have sensors, you got to have essentially optimization, you got to have database and analytics, and you got to have essentially something that is the mapping system associated with the application. Very similar. Only the application software and the parameters and data changes. And then the companies that are able to evolve and become essentially connected ecosystems, they can connect between them into more ecosystems. So you can have essentially connected supply chains, and eventually all that creates an extremely valuable picture in terms of how services can evolve. But we got a little problem here. We got a supply chain from chips all the way to the edge applications, and it's very vulnerable because it's disaggregated. A lot of things can happen in between in terms of people putting Trojans, gray markers, counterfeits, etc. So the question really is, how do we actually secure the supply chain, which is a big, big investment, but do it in a way that we can also make money? We have to understand that there's a lot of lack of visibility. Most of the electronics are assembled in Asia and China. And when the US comes and says, NVIDIA, you will not sell your high-end chips to China, that's ineffective. Because Iran has put about 20 rogue distributor business. They buy chips, they take them, they assemble the drones in Iran, they ship them to Russia, and they go to Ukraine. So fundamentally, you don't have any ability to control your technology and how the technology is used in the end applications. And of course, if you have all these problems, whether these are bugs or vulnerabilities or hackers, they show at the end application. They show up in the colonial attacks, or they show up in what we call the nation-state attacks. So something happens there in a nuclear power plant, and people say, well, what happened to software bill of materials? There was an invasion there. But in reality, if that software bill of materials were linked all the way to the chip and the root of trust, you'd be able to track it down. You can today. In addition, in any of those facilities, nuclear power plants, etc., water pumps that fuel the critical infrastructure, they have essentially an IT department with the boxes of IT that does management, and then they have the OT that manages all the devices. The devices are naked. They don't have security. They don't have the process sensors. So those attacks are very easy to happen in the factory. So where's the opportunity? The opportunity is to essentially establish what we call supply chain provenance and traceability, to be able to track what is going, the assets and devices. And if we can do that in a way that we tackle the security, but also in a way that everybody in the supply chain can make more money, then this is going to be good for the world and the industry. So how we evolve this from a business point of view so everybody can see the value. There's got to be a business incentive in anybody in the supply chain to be able to say, okay, I'm going to participate and collaborate in an open ecosystem of innovation. We start by thinking of how communication evolved and how to create a rapid variation from the days of the pigeons to the Kikamen for marathon, all the way to news, television, etc. And then ARPANET came in. ARPANET came in and changed the world because it created connectivity that was unprecedented. It created the internet, all right? And then, based on that internet, you had companies like Twitter and Facebook that built enormous valuations in literally 2 or 3 years. That's because of that connectivity coupled with social networks. That's the kind of disruption we should see from IoT, except that we have a little bit of legacy infrastructure to deal with, all right? If you look how we built chips and electronic products 20, 30 years ago, we built the hardware and software in one company. I come from EdTech and IBM companies. We actually had a dedicated sales force and a dedicated application engineers to go to the customer, sell it, and support it. Then the industry got disaggregated. You have chip suppliers, foundries, IP vendors, etc. Now you take the components and you have to put them together. So at that point, this is when I was going to a website from Dell, and I was ordering my Dell PC the way I wanted it. I will get it shipped to my home, and then eventually I would have the collaboration portal for email support. But that evolved to e-commerce, sell software as a service, platform as a service, open source licensing. The world now is changing. And that's where we start seeing basically business ecosystems. And the first one was the innovation platforms. The innovation platform is an architecture whereby you attract developers and they build value on top of your architecture. Your iPhone, your smartphone is classic on that, because fundamentally, when you have an app store, the guy who did the app store and manages that platform makes most of the money, all right? So that's the architectural type of platform that attracts enormous valuations on the top of the existing infrastructure. Next one is what we call transaction platforms. Transaction platforms are companies that do not own any assets, but they match make producers and consumers. So you may want to have the people who need a ride, and Uber basically match makes that with the people who have the cars, right? Same applies with Airbnb. They don't own any hotel assets, but they match make the people who need accommodations with the people who have those accommodations. And those are enormous valuation businesses that grow up very, very fast. So what happened during COVID? What happened during COVID is collaboration started growing very much virtual with MS Teams, Zoom, and other collaboration platforms. However, the supply chains remained disaggregated, and although there was a lot of collaboration for innovation, it was not necessarily structured. And we contend that there will be the next generation platforms where virtual reaggregation will occur. So the supply chains will stay as they are, but there will be digitalization, digital transformation, and digital marketplaces. And I wanted to spend a few minutes on that because those are fundamental concepts connecting to IoT and edge in a way that you can monetize. So let's talk about digital transformation. It happens every day. The Minister of Digitalization, the previous one, said we're going to transform and digitalize Greece. What they did is they took all the paper processes and they made them digital processes with digital technologies. Things like CRM, business process management, customer resource management, business process optimization are routine in every function like finance, sales, and HR, right? They've been there for years. Companies like Oracle, SAP, and they're doing it. But what about engineering? What about manufacturing? We introduced the concept of trusted workflow management. The word trusted is important because what you need to do is you need to start logging what's happening in an engineering organization. Internally, you keep that data. You don't give it to anyone else, but you tag it. All right? You tag it, and then later on you have a certificate. Why? Because you have a certificate because you want to know you'll be trusted. We're talking about security, and I'm a big company, but I have rogue engineers, and those rogue engineers put Trojans in there. How do I know I can trust the end product? So I have to trust the asset that's delivered here, and I also have to trust the engineers that worked on it. So that's the concept of digitalization, where basically you use different tools to digitalize, and then you got to secure it, and most importantly, people talk about sharing of the data. I'm going to introduce a new concept, sharing of metadata. Nobody wants to share the proprietary data, but they are willing to share information about the data in a marketplace where people can do queries about the data they may need. And at that point, when that happens, it becomes a private transaction between the data producer and data consumer. And that means that I can actually have my data, encrypt portion of it, ship it, and I get paid. When I get paid, I ship the key for people to use it. Now, this is a concept that talks about selling of data, but in reality, you don't necessarily sell data. In some cases, you do. In some others, you use the data to sell solutions around it, and that's where the money will be. So the idea of digitalization is calculate user stats, flows, and data, create metadata, and essentially start what we call the digital thread of data here. And that data can contain logistics information, design information, or whatever the supplier wants to give. And that, combined with digital transformation and IoT, can lead to edge applications that are much more productive. For example, here, how do we actually take an industrial IoT supplier who provides machinery for the customer factory and connect them, and connect those two in a way that's very productive? If you look at companies like Schneider, Siemens, and ABB, and the guys who provide industrial automation machinery, they are not connected. They're disconnected. They provide machinery, but they're not connected. So somebody puts an order for an industrial PC or a PLC or a SCADA system, it's assembled, it's shipped, it gets installed to the customer, and that's it. There's no connectivity between the supplier and the customer. But if you actually create this digital thread, you can ship a trusted device that is used in the shop floor, right? And together with the software and applications, and as it's being used, the people who are inside that customer, they can actually start using analytics to be able to manage the factory operation. Still, this guy here does not have visibility, but through this connectivity, the DevOps department, the IT department, the DevOps manages those devices, now becomes essentially a smart management. And by the time you actually have this digital platform of connectivity, you can get trusted data back, and when you do that, you can close the loop in terms of edge applications, because you essentially have full supply chain traceability from here to here, no matter how many distributors you got monitoring analytics, and you got essentially digital twins that can be created here as a result of the data that comes there. So now, the important thing about digital transformation is that it is a business process change that is followed by digitalization. Before digitalization, my IT guy used to serve my laptops and PCs, my corporation. After digital transformation, the IT guy is working with the cloud and digital platform, so it becomes a value add function. Same with product management, because now I'm a connected supplier directly with the customer. I don't have to go through this major loop of product management, gathering requirements, creating the roadmap, and eventually getting a new product. All that is happening automatically. This is very important. Connectivity, in the supply chain that leads connectivity to the value chain. So that was digital transformation. The world is moving in that direction, and they usually do it in 3 phases. First, they test it, then you actually make it repeatable to get the ROI, and finally, they start becoming what we call a digital-first business, where everything is digitalized. In order to scale that and grow that very rapidly, they start building ecosystem partnerships. And this is where the interesting part occurs, because if those ecosystem partnerships are orchestrated, it scales the value very, very quickly. So that requires shared data inside, shared applications, and shared operations expertise, where essentially you bridge the physical assets with the digital assets and the capital that is required to orchestrate those ecosystems. And it has 2 components, the entity component and the methodology and technology component. For the entity component, you're going to bring in industry, consortia, academia, and you build an ecosystem like you're trying to do it here. But if you think that Greece is a mini ecosystem, an eco-islands, guess what? In the context of the bigger picture of the trillions of dollars, everybody's like Greece. So the point here is there's an opportunity for small or big ecosystems to participate in this picture to the extent that it is orchestrated. And once it's orchestrated and the collaboration starts, then you can bring technologies like blockchain, etc., then that thing can scale. Now, all those are general concepts. Let's see where I am. I'm 13 minutes here. Good, I'm on time. Now let's go and put that in action to the electronics and IoT supply chain all the way to the edge. All right. This is what Decision says in terms of the growth in euros. And notice here that the first observation about IoT is that it's a platform. It starts with compute. There will be other chips, but the compute is the driver, right? You may have microcontrollers, you may have processors, etc. The remaining hardware, the embedded software, the installation maintenance network, edge platforms, and cloud platforms, depending upon where you are and how the topology would be. So that means that when you start talking about IoT, you need to still think about a platform ecosystem where you worry about the vertical stack from chips to firmware to hardware to software to edge. That's the vertical stack. But there's also the horizontal supply chain, which is the chips. You're going to have 125 billion IoT devices that will drive a $1 trillion industry by 2030. and over 570 zettabytes of data. This is huge. How are you going to manage this data? First of all, you know, it's not just saying, okay, a lot of it may be noise, some of it will be on the edge, etc. So this is where the potential for the growth can be exploited, but it's hindered by supply chain disaggregation, silos within big companies, even companies that have the end-to-end solution, they have silos between the BUs because they're used to sell products that are point products, and the finance department says, oh, you want to build a solution? Well, what about your resources? What about your quarterly numbers? So that's a counterintuitive. I mean, we have some people here that have lived that, all right, in their companies, German companies, you know, because accounting there. So geopolitics is a big one, and security is another one. So we contend that to the extent we can build the trusted digital thread from chips to the edge, that is a key to growing the ecosystem. That is a key to removing barriers to adoption and creating connected business ecosystems. And what a digital thread is a digital flow of data connecting business processes, products, and assets in the value chain. So now, it's not only about, oh, what's my chip and my embedded system, serial numbers of product, but it's also the functionality of it. It has two levels, the asset, and the other is the digital operation of the asset. And of course, that digital operation, that the asset produces data, all right? And data is the new oil. This is where the future is. Everything will be based on data applications, but that requires infrastructure and standards to pump it out. It's unprocessed oil. So, how do we solve this? Well, we're living in an unprecedented geopolitical opportunity that started probably 2 or 3 years ago, or even much more longer, because of the fundamental shift in economics between China and the rest of the world, right? And this is a big issue because fundamentally, technologically, the rest of the world has to move in a way that is not threatening for economic prosperity. So what happened with Gina Raimondo, the secretary of commerce reported to Joe Biden, she basically talked to Thierry Breton at the European Commission, and she went to Japan to talk to Prime Minister, she went to Korea, she built an alliance of about 14 countries. But it starts with the US and the EU, and the $52 billion or $50 billion CHIPS Act in the US, 42 billion euro CHIPS Act in Europe. And those are the government money. And then she went around, and if you add them all up, there are about 600 billion in government initiatives to build 71 fabs in a time window of 3 years. They're being built right now. This is huge. And the reason it's huge is that this is not free money. This requires what we call a private-public partnership money. That means corporations have to also chip in. And when you look at that, it becomes a $2 trillion investment. Huge. What's going to happen to all this fab capacity and all these chips that are going to be produced? They're going to go in a jungle. They're going to go in a wilderness. All right? This is the opportunity to essentially create what we call supply chain traceability. And when we start looking at the global fab capacity, the foundry business is only about 127 billion, of which 5 control pretty much the capacity. So if you look at the global fab capacity, it's controlled by 5 nations, give and take, maybe 7. And that's about 80%. And if you take Taiwan out, that becomes 40%. So you can imagine here, if China invaded Taiwan and took control of it, suddenly the economics world, companies like Apple, etc., will collapse. So the world is in a rush mode to essentially disaggregate and reduce that risk. And don't forget, chips drive semiconductors, they drive electronics, and of course they drive this environment that McKinsey talks about in terms of the ecosystem. So how do we solve this? Well, luckily, if we say we're going to start some supply chain provenance and traceability here at the foundry, we don't have to deal with 1,000 suppliers. It's something that can be contained both at the business level and at the political level between Thierry Breton, Gina Raimondo, and the leaders of those countries. Because all we need to do is to basically say, oh, you're building a fab that's going to cost you $100 million. Well, out of those 100, you need only about 10 to establish the software traceability of tracing everything that you do. It's not a big deal. It's just, you know, something that people do routinely as part of digitalization. So that's huge, because if you establish that initially, you establish the initial digital thread where the supply chain works. So it's an opportunity, that as a member of the IoT Advisory Board, I'm screaming and saying, politicians, this is the time to change the world in terms of putting a digital thread. And in order to do that, you got to just have an orchestrated approach. You basically take three major domains, the semiconductor ecosystem, the electronics ecosystem, and the edge ecosystem, and you classify companies in them and the experts, because domain experts tend to work closer with the domain experts. And then you essentially create a model of the supply chain where it starts with the root of trust. And the root of trust, basically, you have two kinds. A physical root of trust is to attach in the wafer, and you can track with scanners, pretty much the same way you put a QR code, an RFID, etc. And that's for the asset. And then a digital root of trust that you put inside the chip, fingerprint, security, and sensors, and sometimes, that you can use to track the design. So every time you turn on the power on that chip, you basically know what data goes in and out, and you know if somebody went with a pita bread and the listening device and steals your keys. Because that happens when you turn on the power. They go, you just go Google the pita bread stealing of the device keys and you'll be fascinated. All right? So this is important because when you start with the root of trust, then you can start developing what we call key chains in the supply chain. And those key chains essentially can enable the security across supply chain. Right? And that's the security paradigm that everybody knows in the business. That goes from a root of trust in the chip to packaging all the way to the system. Today's systems are based on TPMs that basically are the platform mechanism for securing the device and onboarding the device, etc. So then, if you start here, you establish the digital thread here, which is very important. And you essentially move to the digital transformation, as we said before. So, and that basically starts with chip design and manufacturing. Because chip design and manufacturing creates the most data everywhere, from verification, from design, from IP, from metrology, from testing. It's probably, for chip design, you can talk about automotive manufacturing, but chip manufacturing produces enormous amounts of data compared to other manufacturing facilities. Then, the next thing you need to basically monitor the hardware, the assets. And the assets will be hardware, software, or what we call a combination of both, the digital bill of materials. In the digital bill of materials, it's not just hardware and software, but cross-references for that. Because the manufacturer here may have a part number, but the distributor may have another part number for the same thing, because they provision it differently for the application market, and the customer may have a different part number. So unless you correlate those part numbers together, you're never going to have true traceability. So tracking the assets is important. So you know if that chip ended up in a rogue distributor and it was sold to Iran and eventually went to Ukraine, you need to be able to track that. And finally, once you turn on the power on those devices, they will produce data. So the question is, can we incentivize the enterprises to digitalize their operations, receivables, workflows, deliverables, so that we basically link the operational part of the asset with the actual asset being secure and trusted. And that will enable what we call digital marketplaces. So what are digital marketplaces? Are essentially a marketplace of data producers and asset producers, of course, where the data they provide only info and services, but not necessarily the data itself. And the consumers who essentially look at the field use and provide information about the field use so that we can bring them back to these guys and build the digital twins. So I'm not going to go into detail on that, but I'll give you a few examples of why the digital thread will enable economic growth for everybody in the value chain. So if you think about the functions of design, chip, manufacture, package, distribute, test, and certify, or the functions of the system, assemble, procure, provision, onboard, etc. Each and every function is based on some data, right? And each and every function requires certain applications to be carried out. So for example, I'm not going to show them all, but I'll give you an example of key ones, all right? The first one is secure chip enrollment, where you configure what access people can have on the chip, and also start the digital thread. That's an important part because this is the birth of the chip in manufacturing. The very first time you do the power up, you've got to basically register it in a secure server with its own fingerprint. And no matter who the middleman is, an automated test equipment or a PCB or a system, at the end, that chip should be able to be recognized through an API to a cloud. The next one is, before that chip goes to systems, to make sure that it's authenticated, that it's cross-referenced in terms of what the digital bill of material names are, that you have all that paper trail in it, and also add what we call a digital certificate, which is not only a security certificate, but it's also a trust certificate relative to who did what when in the supply chain based on those identifiers that I showed you before. Another big operation is when you receive that chip and you receive it with all the other parts, all the hardware and software bill of materials, right? You got to essentially put them together into a PCB, into a system, and you got to have a trust score. And today the only trusted chip that exists pervasively in the marketplace is a secure element or TPM. But you want to have that in the microcontrollers that have security, you want to have it in the processors, you want to have it in the flash memories, and eventually every piece has to be trusted, and that trust score evolves and becomes essentially higher. You perform an electrical test, that means you essentially open up the power, turn on the power, and if you turn on the power, you want to make sure that this device has the same characteristics as originally intended. And from that point on, you can do different things. You are ready to go to deploy the device. You need to create a security policy because that device may go to Brazil, it may go to China. Configure the license rights, secure the device, do the secure device onboarding, and from that point on, you can operate remotely. So now, you can add whatever apps you want. But I'm giving an example of apps. What is your high-value app? If you say I'm playing on embedded business system development, I got my inputs, I got my outputs, I got my process. What's my data? And how can you develop apps on top of that data? If you start thinking about that, you're going to sell the hardware as a razor, and your data will become essentially the ability to sell razor blades, either in the form of data or applications around it. We'll give you some examples. We have Keynote here, one of the sponsors. You build a chip with the test BIST and a fingerprint security. It goes to a car, it goes to the ECU, and essentially you have this functional safety issue, FUSA, right? That particular chip is about to fail. You can basically take a kind of product to a parking, get the data, and do analysis on the chip and see what is the cause of failure. That's for the chip supplier. For the OEM, you can look at fleet management and be able to collect statistics across all these applications and be able to do analytics. Next one is what we call the multi-market product, or a chip that has configuration in terms of the features that are available. This is Intel introduced that recently called Intel Pay-As-You-Go. I give you a chip, it has certain features. If you want more, I'll turn them on, you pay me a service fee. All right? So now, the same that Tesla did when there was a hurricane.
Do you want me to give you a wireless?
Can you hear me? Do I talk loud enough? Can you hear me? Okay.
I'm streaming and it would be better if you had a better sound.
Okay.
I can give you a wireless microphone.
Yes,
if you like.
that's much better.
Okay.
So here, a multi-market product has different features that are turned on upon demand. All right? Like when Tesla turned on and did an upgrade on the car to evacuate the Florida hurricane residents, they gave them an extra 100 miles. And people said, wait a minute, you had a product and you sold me a car and you had the ability to do another extra 100 miles with a charged electric battery, and now you charge me extra? So of course, yes, that's a service. That's product as a service. Thank you. 1, 2, much better. Okay. If you're an industrial, you may ship devices that are the same devices to adapt to different network environments within the same supplier. 1, 2, good. So this is very important. Configuration when the device arrives is very, very important relative to the application market. That configuration is worth money. Third one is for military applications. The DoD companies and put airplanes, they say they go through extreme stress in terms of how the chips are being traced, in terms of migration, bias temp, etc. And they cannot carry a tester with a chip. So what they want is they want you to build a self-test situation here with sensors and a fingerprint and be able to get that data and do analytics and see how this chip is basically not only aging, but is being stressed out in the environment. And of course, my favorite one that requires both asset traceability and design traceability, you got to be able to trace the asset from a rogue distributor that bought this chip and put it on a drone and it went to Ukraine, and you want to be able to just put a command, and disable that sucker when it's in enemy territory, or they want to use it for a cybersecurity attack. That's called regulating market access and market use. So how do we accelerate this? How do we accelerate this closed loop, which if it happens, everybody's going to win, everybody's going to make money, and the growth is going to go like crazy? Well, the first thing is that we've got to build a collaborative ecosystem to drive the infrastructure part that is needed, starting with the root of trust, the keys that essentially, security keys that derive from the root of trust, the ability to provision devices and chips for market access, market usage, then the ability to maintain the data confidential, and that's different than data privacy. Data confidentiality is the enterprise data, the device data that I want to basically protect and I want to be able to monetize if necessary. Then eventually make the upgrades, both hardware and software, very easy to use. This is very important. And finally, architect the system for the end application is going to go to smart cities, etc., with lots of APIs to allow for interoperability. And if you think about this picture, you do not necessarily need a lot of standards, but what you need is to do a taxonomy of the existing standards today in the value chain. And you can see here, starting from the environment, we got IETF that worries about the software bill of materials and how do you deal with supply chains there. But that software bill of materials is linked to devices that are being onboarded using the FIDO secure device onboarded and originated with Intel. The Trusted Computing Group, the IPC that collects essentially chips into PCBs and chiplets into new systems. The JEDEC that does the cross-referencing of the serial numbers and the numbers, because the manufacturing product number is very different than the distributor number. And eventually you go to SEMI that does the secure testing, etc. So the taxonomy is there. Most of the standards are there. What's needed in the electronic supply chain is what the SAE does, which is defining the inputs and the outputs between the different places of the supply chain. And once you define that, they become essentially the basis of the data sets for the digital thread. And then once you do that, you start thinking about economics. And the economics start by saying, okay, I'm building a fab, I need to get the ROI. What kind of data do I produce? Who needs that data? Lockheed comes and says, I just bought those chips. I don't want to spend 100 person years to essentially test them. That test data exists in the foundry. I'm willing to pay for it. It's actually much cheaper for me to take the test data as it is, as opposed to testing it myself, and use it to build digital twins and simulation models before I even built the Alperlink. So that's very, very important. And eventually, everybody makes money in everything as a service when you reach the end application, which is what we call the everything as a service. Okay. Now, one more thing. How do you actually proliferate that? Well, you got a few marketing vehicles. The first one is announced by the White House, and by the way, I have links, you can go look at them. It's called the Cybersecurity Labeling Program, CyberTrust Mark. All right. And the second one is an EU-born thing, which is extremely important. In the next picture is called the EU Digital Product Passport, DPP. So let's talk about how those can round up the picture of scaling the IoT value chain. So the IoT cybersecurity problem, you can go to White House, you can go to Carnegie Mellon University and learn more about it. But CMU did a research with the consumers and say, what do you care about more when it comes to security? And consumers said two things, security and privacy. So they took that and they said, we're going to create a cybersecurity label with a QR code, and every manufacturer of a device that's used by a consumer, basically, if you want to be trusted and you want to be bought and be differentiated, you got to basically say, I did the security certification, I did A, B, C, D. That's just a label. We don't know if they did it, but it's a marketing vehicle that creates proliferation. So, and that's very important, okay? But it does not solve the traceability problem. Whereas, on the other hand, the DPP has something very interesting. The DPP evolved from a circular sustainability market. You know, they did that traceability, and as they started doing this, they discovered that electronics creates the biggest recycling issue in the marketplace. So they said, we got to trace the electronics. And by doing that, they started thinking in terms of what do we do in data? And these are the discussions that are going right now that will basically become, they'll be brought to the EU in 2024 for regulations. And I love EU regulations because EU says, here's my regulation, I'm going to give you cobblestone and you follow it. US says, I'm going to give you a highway for 6 lanes and you can go whichever you want. But in this particular case, we need that regulation whereby we define where do we need strict regulation for data, when do we need loose regulation about data. But more importantly, look at this. They're talking about data carriers, identifiers. That's for asset tracking. But what they did not do is to add the root of trust. So when you actually add the root of trust and link it with the assets, you create a complete picture of supply chain traceability with a digital thread. All right? And then the rest follows, because fundamentally, if you look at what Catena X is doing for automotive and what Gaia X is doing for data platforms, those are, I'm assuming some of you know about those. They're European things. All those come together with the digital product passport, and eventually you can put labels in products, and suddenly we're becoming a connected world when we can create what I call a digital paper trail for every asset, not only in terms of the physical asset, but also in terms of its operation and whether it functions and performs as originally intended by the foundry and the designer. So, how do we do this course globally? I have about another 5 minutes. I hope, sorry to run a little over. The first thing to recognize is that semiconductor fab is based on rare earth metals. You got to build, and those come predominantly for China. Then, if you look at the semiconductor components, flash memory, accelerometer, controller, LCD audio chips, and eventually GPU and CPU manufacturing, all those come from all over the world. And then you look at assembly, and that goes in China. So that's not a good picture, because we basically, from the beginning, we rely on China, at the end we rely on China, okay? So I'm not saying China is bad, but traceability is necessary for being able to evolve. And that's where essentially the digital product passport can have a global impact. Because once regulations come in, and electronics start crossing borders, others and other nations that will start basically seeing the value of it, and that will inspire cross-border collaboration traceability. Then the cybersecurity labeling program, or the equivalent the EU may have, Australia has a different name for it, will essentially provide visibility, empower businesses and governments to basically make informed decisions. But what needs to happen also is the border protection and customs, all right? And this is something that was announced recently. The U.S. Customs and Border Protection launches the Global Business Identifier Pilot to essentially identify all products that cross the borders. And that's based on a GS1 standards called the Global Identifier that sits on the top, and underneath you can put RFIDs, QR codes, root of trust, etc., and all of those can be tracked together with a digital thread. So that's an important development, and standards you should keep in mind. So as an advisory board member, I've already made my proposal about supply chain traceability and digital thread, not just for supply chain resilience, but also to create businesses that will have more products from data and accelerate growth. And those are the 3 pillars of policy. I'm not going to go into detail because you can go into this link and look there. You can look what the IT Advisory Board is advising the Department of Commerce. But fundamentally, it's different things in terms of what the private businesses can do, what the combination of the private businesses and the government can do, and what the government can do. All right? But to create incentives so that the ecosystem moves on in this direction. So, at the highest level, what we're saying is, Secretary General Raimondo, you can leverage, together with your remit on the US and EU CHIPS Act, toward a global collaboration. This is the time to do it, all right? And the way to do it is orchestrate an ecosystem of companies across the value chain. Semiconductors, embedded systems, edge applications. And that's not the rocket science. It can be done very easily. The White House proved that it can do the multi-stakeholder collaboration with the cybersecurity labeling program. And then invest just a tiny bit of that CHIPS money to do what we call low-cost pilot programs to prove trusted digitalization driving economic growth. Because you can actually show the value of the digital thread starting in semiconductor design and manufacturing, then it will proliferate. At that point, you can start promoting that to the global international allies, start adding essentially digital product passport and cyber trust mark as a means to accelerate adoption, and the world move in that direction. So fundamentally, The idea is to promote trusted value chains that strengthen national security or international security and drive trillions of economic growth. I truly believe that if the Department of Commerce and Thierry Breton and the US and EU work together on this, they could actually drive trillions of economic growth. Now let's go down to the more technical part and see how we start a digital thread. Right? Here's now semiconductor design and manufacturing. That starts the digital thread, the provenance of it. You're going to have an IC design house, a foundry and packaging house, and then eventually they ship something to the OEM and the EMS. Okay? Each and every one of those enterprises will have a local server that may maintain some data, some of which may become available or not. So what happens, the chip designer needs to put a security IP system with a fingerprint, and typically the best way to do it is together with a design for test infrastructure and the BIST, because this way you maintain essentially, you create a security in the fingerprint with data from the chip that is tied to that fingerprint. And in this design process, all they need to do is basically digitalize and maintain some IDs on who did what when, and create what we call a design certificate. So that's a trust certificate that I follow the trust process. If you're in the IP business and offering IP, that is something that you need to do, because IP compliance, people will not buy IP in the future if it's not trusted. So you got to have, if you're doing RTL IP, it's easy because it's like software development. You have your software development tree, you know what you did. You know, I did once upon a time a software and I can still know who are the developers, right? And who did what when. So, but that's kind of important. The next is you ship that design data, and the foundry will do two things. They will add a physical identifier. It can be a QR code or RFID. And it will also add, you know, they will also create automatically, because of the security that you put there will be an identifier that will be created during test. So upon the first power up, what we call the chip birth, the fingerprint is created, there is some data exchange, and that chip develops essentially a trusted relationship with the server. At that point, you ship the wafer, which is not singulated yet. The reason we put an ID here is because, you know, for each die, is because later on it will be cut, and you lose traceability. So then you go to the OSAT, that wafer is being cut, it's put into waffles, and eventually those chips are tested in a package. And eventually, at that point, they will be put in a box, an identifier has to be done, and a chip certificate has to be created, not only in terms of security, but also the trusted process followed. If you think about this particular certificate, this is nirvana for the recipient, because now they can build what we call a platform certificate that factors all the chips that they get from different supply chains, right? And that's basically the chiplets or PCB, you need that. Now, what you need for that to do it, fundamentally, you need to build a chip in a simulation environment that basically models how the chip operates in supply chain, including the middlewares, on, if it was in the tester or in the debug environment or the PCB, to be able to essentially understand what data will come in and out. And what's needed in the foundry is essentially a secure environment with a local server with HSM that gets the data, passes it through a gateway to the cloud, and eventually you establish that connection. This way, the first chips in automotive, industrial, and aerospace defense will be in analytics. That conclusion, what does it mean for you? Well, whatever you are in this value chain, the first thing you need to think about is not only what your product is, but also how your product plays in the value chain and how your company fits in the value chain. What are your inputs? What are your outputs? What's your process? Because if you think about that, you also think about the data that you create in delivering that product. And once you know the data that you created about delivering the product, you start thinking about how to protect it and monetize it. Next one is that you need to basically start thinking platforms, because platforms will go from hardware all the way to edge. You may not have all the solutions to the platform, but you have the pieces needed for the platform strategies that will evolve in Europe, and there are many, many of those happening right now. And at the end of the day, when there's money coming in from the CHIPS Act, you'll be looking at essentially private-public partnership pilots for platforms that could also enable, essentially, given the embedded software and expertise in Greece, to start thinking about PCB assembly in Greece to take it away from Asia. When you design IP, chips or systems, make sure you put fingerprint and security keys tied to a root of trust. Because that linkage basically makes the product very valuable. And of course, you're going to put your security for secure boot or secure storage, but what matters also is secure data access. That's what develops the digital thread. You partner with founders or OSATs if you actually build a chip to essentially say, all right, how we can do a secure chip enrollment at birth to make sure that this chip is known, and as it goes through his journey in the supply chain, people don't mess with it. We enroll it, and it eventually gets to be participating in the over-the-air management in the field. And finally, don't underestimate, very important, the PLM, the software PLM vendors that develop the enterprise tools for digitalization, whether this is operations in manufacturing or design, are going to play a key role because they digitalize those processes, whether this is IP design, chip design, manufacturing, etc. Those workflows are being digitalized and eventually connected to the DevOps that connect to the edge applications. That's basically the whole picture, a very complex, very big picture that only governments can drive through orchestration, and the private sector participating there, particularly the big guys, have to invest in order to build that picture. But if they built it, everybody wins, not only in terms of security and supply chain resilience, but also in terms of monetization because of the digital thread. With that, thank you very much.